The distance formula. You should have learned about the distance formula in Algebra 1, but we're going to review it really quick here. If I look at this graph that they give me, I've got two coordinates, x1, y1, x2, y2. They don't give you any numbers, and for some of you, that's very difficult. So I'm going to walk you through this. Hopefully, it will be a little bit easier as I'm showing it to you. So if I click right here on the distance, because this is an example, it's going to walk it through with you. It says the distance, d, relies on the horizontal and vertical changes. So basically, what's the difference between these 2 points? Okay, but to be able to do that, you can't count on a graph at an angle. You can count perfectly horizontal and perfectly vertical, but anytime there's any kind of slant or slope, you cannot count that. So you have to calculate it. So one of the ways we can do that is through the Pythagorean theorem. It is a right triangle, so you can use the Pythagorean theorem. Hopefully you remember what that is. But if a triangle is a right triangle, a squared, whoa, that's terrible, plus b squared will equal c squared. And remember, it only works if it's a right triangle. So you would need to find, if I called this a, this whole distance, and this whole distance b, I would need to square that. Well, the distance is just the difference between the two coordinates. So of the x values right here, x1 and x2, I'm going to find the difference. So a is just the absolute value, absolute value, that's a straight line, of x2 minus x1. Let's see if I can make a straight line here. Ooh, close. Okay, so absolute value of x2 minus x1 squared, because it's the distance, a squared, plus b, and again, absolute value of the y coordinates, y2 minus y1. Absolute value squared equals that distance that we're talking about, d squared. There's the c. So you have a squared, which is the horizontal components, and you have b squared, which are the vertical components, squared, should equal the distance squared. So if you look down here, hopefully, it's a little bit hard to see, but if you look down here, it says, hey, that's similar to what we just said. It's just they put d squared first. And then the next step is taking the square root, because we want the distance, not the distance squared. So to get rid of a square root, I'm going to switch colors. You take the square root of both sides. And that's how they get d equals to all this stuff right here. That is the distance formula. And it comes straight from the Pythagorean theorem, which is kind of cool. So here's the conclusion. It says, conclusion, the length of PQ, so from point P to point Q, is the distance between points P and Q, and this is the formula. So if you do not have this written down somewhere, you are definitely going to want to write the distance formula, and you might even want to write distance or distance formula near that, because you're going to need this again in geometry and in algebra 2.